Hey, good morning, Tim.
Morning, Ella. How you doing?
Good. How about you?
Good. Good. Can't complain. This is the last meeting of the day.
Yeah.
Hey, hi, do you know if Sana is going to join us?
I don't know.
I just dropped a message on the Slack. Let's see if she responds. I guess Alex is still on vacation, right? I don't think he's going to lead this meeting.
Yeah, I don't know how long he is gone.
If I remember, I said 15th or something like that. I'm not sure though. I'm not sure if Sana is relying on Alexi to chair the call today.
I have the feeling this will not happen.
Yeah, so Santa was coordinating the meetings. Alexis is on vacation. I'm looking at the. Okay. Yeah, she's got some questions on the release notes in Q1, but I don't know, guys. I'm going to drop. I'm not quite sure what she's going to want to try to accomplish. Oh, she's on. Santa, you're on. Santa, if you're speaking, we can't hear you.
Hi, Tim. Sorry, I was late in joining. I had some problem with my PC restart and it just took me some time to get here. Tim, can you hear me?
Yes, we can hear you. Yes.
Okay.
Yeah,
Okay,
we
perfect.
can.
Is everyone here, or do we have just these guys here, or did someone drop already?
I'm not quite sure. I wasn't keeping track. We've only got 8 though on this.
Okay.
meeting.
Okay, all good. I think we have lost 8 minutes already. I will just get started. I think the first part of my agenda that I planned and basically published was to basically have someone from SIG 2 and walk us through the release, R2 release. And we could actually bring everybody on the same page in SIG 1 and we can ask questions.
Mhm.
Can you
I'm
help us with?
here.
Okay, excellent.
I can try to help, but I haven't prepared because I thought Tal took the action, so we didn't.
Wim, let's keep it casual. Whatever you can bring to our attention. Like you have heard the user stories a little bit. I want to see that everybody at least know what exists on the ground. Like how do we build from there? And that will actually help us brainstorm better user stories for the scope of R3. It's just that exercise.
Yeah. So, okay. Where do I start? I assume that people understand R1?
I think people do, but a recap won't hurt. Let's recap on R1. Then what did we do on R2?
Okay,
How did we build?
Let me take my slides. Let's take it from there, and then
I think the TSC slides has some recap. Will probably, I'm not sure. That's a good reference.
The TSC slides from
The last couple of meetings, like they've been presenting there, right? Oh, okay.
But I'll take my slides that I did yesterday or during the weekend. I did a presentation and post them. So Google Slides, where are they? All right. I also have some slides on some of the things that we did. So, all right. Okay. share screen. Okay, yeah, so I'm using just this slide for the time being, right? But we'll delve into more stuff, right? So basically, so this is kind of where what we start from, right, as the basis. So we have a package, or we have multiple packages, right? That and actually today we have mainly two use cases, I say, that we enroll through this package framework. One is I call it a more infra-focused one, and this is to set up clusters and the connectivity between the clusters. And then we deploy network functions on top of it, right? So the way it works, so everything that we are doing today is through a package, right? So I hope everybody understands what the package is or what the package does. So here is an example of a package is represented here. Okay, so this is a one from a network function. So what are we doing? Basically, we say, okay, this is a network function of a certain type. Let's call it a UPF. And then we identify a set of what we call requirements. And those can be, for example, this is an example of this UPF needs to be connected to 3 networks. So one is A, B, and C. And so you basically put in that package resource that identifies the requirements towards that interface and towards that network. And by doing so, we are going to use that later on to then specialize that data that is being requested. Okay. So in the release 1 scope, that was limited towards infrastructure information. Okay. So what it meant was, for example, if we were to configure a PLMN ID or some specific 3GPP parameters, if you will, or specific vendor parameters that were related to a specific network function, they were hard-coded. Okay, so in the release 2, we came up with an ability to add either vendor-specific or what we call the configuration CRD, so specific configuration snippets that might be of interest for that particular deployment. So an example of this is, for example, the images that you use for a particular deployment. But for example, we also did a use case where we had specific 3GPP parameters being let's say specified, and we basically pass that through the specialization pipeline without doing anything on these, and that we give it to the operator that lives into the workload cluster. So in other words, so why am I saying this is that this package is kind of at the moment our vehicle to convey information, and we made it. So in release 1, we had some requirements that were identifying infrastructure requirements. In release 2, we made it more generic, such that we can convey specific configuration parameters or vendor-specific attributes that are necessary for a specific workload, right? So that gives us more flexibility, if you will. But anything here starts always from that package. And so we have, in essence, from my perspective, we have two use cases that we render through this pipeline. One is the setting up of a let's say a cluster and a network on which those clusters are connected. So what we do, for example, for a cluster, we also have a workload cluster package. And so in the meantime, so when our sandbox uses cluster API, which is using kind, so we have the Docker provider. So the nice thing is it's so it's recursive, okay? Which means that, so in other words, the recursion, so we have this concept of a package that goes through, we can say we start from the package that I showed you here, sorry, is actually what we call a dry package, right? So it's basically, you cannot deploy this, right? Because it would, the parameters inside of it would be not specialized, if you will. So it's what we call a dry package. And so what we can, for example, do is in order to make a package wet, if you will, so basically specific to a certain context, we have a concept of a package variant controller that basically identifies the specific context in which that package would be rendered. And as such, we then specialize it with all the different parameters that are related for that specific instance of that entity. Okay? And we apply that to both the cluster side as well as to the network function side. So for example, in clusters, so a workload cluster needs a repo, right? Because we still, at the moment, we create a repo per site or per cluster. We need a token to connect to the repo. We need a GitOps tool to basically connect the workload cluster to the management cluster and get all these artifacts. We need a CNI, we need a storage, and so on and so forth. So in other words, there is a set of packages. So so the way that it's designed is actually with inheritance, right? So you have the root package, if you will, which is the workload cluster. And that root package calls upon a repository package, which basically deals with repositories. It calls upon a CNI package, which calls upon CNI specific stuff. It calls upon a GitOps package, which does then the GitOps specific. So in other words, those packages, when we use them, they are, let's say, chained, or they can inherit other packages. And so they can recursively trigger additional things that need to happen for that particular instance that we want to deploy. Is that clear? So in other words, when we start from a package variant for a cluster, let's say we need 3 clusters. We have a package variant for cluster A, another package variant for cluster B, another variant for cluster C. In that cluster package, we have a pointer to other package variants that are instantiating, let's say, repositories, CNIs, GitOps, and so on and so forth. And that will then instantiate further recursion if that would be needed, and so on and so forth. So in other words, we can build these building blocks that are, let's say, customizable in a way. So I call them Lego systems. So a package is kind of a Lego block, and you can recursively call upon that, right? And during that instantiation, so when you basically say, okay, I'm going to instantiate that package, we perform the specialization to make that then, to specialize it for a specific instance that you want to deploy. And by doing so is we give a context, and then we can identify the requirements that those packages have, and we make these identifiers specific to the environment on which they get deployed.
Hey, so
Now
so
there has
Wim,
been some.
hey Wim,
Yeah.
so
Yeah.
so how do you designate injection? How do you know what when you're injecting or specializing? You know, once you fan out, how do you know what phase that is? Right? Is it all through the function or what?
So in the package, right, there is a pipeline, right? So and during, so you don't see that here, but actually you see, so each function or each step into that thing is set up through conditions. So Kubernetes works with the concept of conditions and readiness gates. So we are using that concept to identify what work is still pending and what work is done or what work did not complete. So the conditions and the readiness gates identify the steps that have been executed, as well as the status on which that execution is at.
So where are the
Right,
readiness gates on the pipeline then? I guess that's what I was asking.
So the readiness gates is at the moment inside of the package. So if you look at the UI, you can actually nicely see what is going on, basically.
Okay.
Right.
I have a similar question. I think similar to Tim, where his basically thinking is coming from. So what we are seeing on the screen right now are basically the blueprint packages and the deployment manifest for a UPF deployment, right? And UPF, in example of the R1, I believe we use the free 5GC UPF. Now, based on our UPF requirements, whatever infrastructure requirements do we have in the terms of the cluster context or the types of interfaces required or CNI plugins, we know that ahead of time because we probably have seen the Helm chart or we know the requirements, right? So based on those requirements, we prepare these artifacts ourselves, right? And from the base packages, that is the blueprint packages, we're applying all the extensions and customizations for the deployment manifest, which is basically preparing the infrastructure for the incoming UPF deployment, right?
Yes.
Now I have a couple of questions.
Yeah. Okay. So there is a few things that you have to bear in mind at the moment, and is that some of these, like today we have a requirement on Multus, for example, right? So there is a set of dependencies that we pre-install. So in other words, the triggering of the net. So we have what we call so we have a task force that I'm actually leading, which is NF2 Infra. So today, the Multus installation happens during the cluster creation time. Okay. So, and I think Eric and Bernard always ask the question, even in R2, right? That they say, okay, I actually want to say I need a network function and all the rest will happen automatically, right? So I don't care what is there, right? So the system figures it out. We don't have that yet. We are working on that.
So this is a roadmap, and of course I also want that. I'm just like Eric and Bernard in that wish that my intent is to deploy a UPF, and I'm only giving you the UPF artifacts because maybe the vendor gave me the UPF Helm charts, or ideally maybe the UPF operators and CRDs in the future, and just with that one artifact, I give it to the system. And the system determines the requirement for the infrastructure, the CNI plugins, the VLANs or the interfaces, the day one configuration files and the IP addresses, everything from that initial package that I was given to the vendor. The rest system should extract, apply, do the magic, and give me a functioning UPF. Like it's a roadmap, right? This is the picture.
Yeah, we are working on that. Yeah, so I think we have a concept worked out to make that happen. So we are working on that as we speak.
Excellent, Wim. Wim, I have another question based on what we are seeing on the screen. So because we have a lot of vendors, right? And all those vendors would have different types of CNI requirements and sometimes different number of interface IP addresses that they need, different variations. Walk me through again with the concept. How does the basic Legos building blocks creates the list of least common denominators and it's kind of reusable across vendor to vendor, and it could still serve that? I'm sure you explained, but walk me again.
We don't care at the moment. So let's say if a vendor needs 5 interfaces or 1 or 2 or 25, we don't care. So how you accommodate that is that the package itself, you put 25 requests inside if you need 25 IPs. Or if you need just 1, you just do 1. You see?
Yeah.
So
is there a logic somewhere? Like, how do we write the logic where it just, or maybe we're not there yet, where it just reads off of the requirement that this particular network function requires 25 dedicated interfaces. So I have to spin 20 blocks of this package.
So that we did not. So we didn't go there yet, right? So so we at the moment, you remember when we did the R1 conversation, is that we said, okay, the package is generated from a set of smart people at the moment. You want this to be automated, but at the moment it's a set of smart people that say, okay, for this deployment, this is the requirements that I have, and those at the moment are manually assembled. But we can, I mean, if there is, a system that we could use or some logic that we could use, we could derive it from that logic potentially. That's not a big thing. It's not a huge thing to solve necessarily. I mean, it's fairly straightforward to do that type of thing.
Right. It will be. When you talk about, like, for now, I'm happy where we are. Of course, this is making progress there. Eventually, it will be important. So, for example, if you have a UPF with 85 microservices, and for that grand size of a UPF deployment, you need 17 interfaces, then doing all of that manually and stitching all of that manually would, of course, be work. And then when you have to deploy 45 of those UPFs, like in a short time, then you need aggressive automation built into your effort so that there is less manual work in between how we are managing the automation templates, right? So it would eventually become important.
Yeah,
but
what I'm trying
Sarah,
to,
if I understand, I mean, here when we talk about interfaces, we are only talking about the standard interfaces, the 3GPP interfaces, like how they map to the underlying microservices is about vendor specific details that is handled at the cluster level, right? So I'm not sure where the scalability, and if you talk about fan out also, that's fundamentally handled by the package variant set concept, where you are actually fanning the UPF among, say, 45 clusters. So where do you see this 45 interfaces? I mean, is that something you see actually in reality?
Yes, in my production deployment, I'm currently working on a UPF deployment in production. I'm giving you the actual stats of that UPF right now.
Okay, I mean, there are like interfaces beyond the standardized interfaces in here? Or?
There are some vendor-specific implementations as well, right?
Yeah,
okay. No
yeah,
problem,
Ravi, I mean, even for us with Nokia, right? So for every pod, you have a set of interfaces potentially. Then you have load balancing less and load balance full, and all kinds of stuff, right? So based on that, you have different. The thing that is here, so this doesn't change, but the amount and the type changes depending on the vendor, right? So what you could do is have a tool that basically from the vendor basically generates this, right? So that's what I'm saying, is that what we have to build a sample of to generate that such a package is constituted from a set of inputs, and then you can automate that, right?
Right. And Wim, another question, because it's also relevant to the concept of very large CNFs with large number of microservices. So today when we deploy that with Helm chart, I know that deploying that with Helm chart alone, the Kubernetes layer doesn't give us the visibility into that deployed microservices as one entity, because Kubernetes is not the kind of orchestration that can manage an application that spans multiple clusters and that spans that type of volume in terms of microservices. So we have a concept that we have to develop something in a higher level modeling template, like we do something with Tosca. And of course, with that Tosca, we had the topology files, and then with that topology, we know that these 85 microservices is one entity. It's one network function. Now we can do all the other things on top. We can talk about scaling it, healing it, or doing the software upgrade. So where are we with Nephew in terms of the higher level modeling? Have we not touched that at all? Like, I know that there is a modeling working group and we're talking about that, but in the current releases, we have not touched that concept yet, like a higher level template that manages the lower level artifacts and kind of builds the topology and
yeah, we have a topology. We did a topology controller that basically not from a single NF, but multiple NFs, right? So where you have let's say SMF, UPF. So that was a prototype. We did not 100% validate all of that, but there is code about that.
Okay.
But I would say it's in prototype stage.
Oh, that's very important. So yes, I think as we talk about the evolution of these releases, we mostly focus on the use cases, but I think it's very important to understand from SIG2's perspective, how is the evolution of that going, and what is it that SIG1 can do to offer something that can extend on that effort beyond what's done. So keep going. This is a very helpful session.
Yeah, so this is kind of a bit. The point is, I mean, we have touched upon that in the beginning, or at
Right.
some point in R1. We didn't go very far here because that's the domain between the service layer, service orchestration, and the domain orchestration. So that's why it's a bit, has been a slippery slope. So we haven't, done a lot of work in that space. So that's probably worth a discussion where we want to get there, or how we want to evolve in that space, right?
Right.
Yeah. So one thing that is maybe also unclear, right, Susanna, it's one of the things that you raised recently, I think last week into the Slack. We have a kind of inventory system that we use, by the way, at the
Yes,
moment.
please go ahead. Yeah.
So in order to for example, set up the connectivity between all the clusters and stuff like that, so there isn't, so when I built the backend system, which is doing our IP and VLANs and stuff like that, it also has topology. So it has a concept of nodes, links, and endpoints. And as such, we know all the clusters, where they are and how they get connected, right? So, and we use that during that specialization phase to actually allocate the right resources towards the right elements, because otherwise, just having an ability to say edge 1 and region 1 and stuff like that, without that, you cannot basically interconnect stuff, right? So we do have, that's already there since release 1. I have a set of, it's a very basic thing, an inventory system that has the topology, as well as some resource identifiers that identify location and stuff like that. All right.
All right. Where do we store IP addresses?
In that backend.
Okay. Is there like a microservice or component for that?
Yes. So that's a controller. So then they are all separated. So IP, VLAN, topology. I've added VXLAN. So they're all independent controllers.
So in the true production deployments, telcos better, right? We also have the requirement of these static IP addresses. Like we assign those static IP addresses to certain interfaces. And unfortunately, in our situation, those static IP address assignments is kind of not fully IPAM driven. Like it's partially IPAM driven. Some of the steps are still manual because of the security compliance and things like that. What is the best way to manage that? What is it that we could offer in Nephew to handle that?
So for example, the IPAM, you can allocate a static IP, you can just register it, and then we can use it to convey that information. For example, sometimes that IP wants to be known by someone else, right? So one of the things that I'm adding to it is I'm adding a DNS to that system using Core DNS plugin. I started to looking at that. So we can use it as a DNS server, but then for cluster wide, right?
Okay.
Not within cluster.
Do we have a local IPAM as well within Nephew or no?
So at the moment, so that IPAM, by the way, you can deploy central or local. So someone built that's a Nokia guy, because we are using it at the moment for private wireless, for example. He built a CNI plugin into it, so it uses, instead of Wetabyte, they are using it to get IPs to the local CNIs within the cluster. Because
is
you
it an
have
open source component, or is it
it's fully open source.
Can you share the pointer to that after that, Wim, the IPAM component that you're using within Nephew? Okay.
We were built. It's built within. It was built during the Nephew stage, by the way.
It was in R1 as well, right?
Yes. Yeah.
Perfect.
So so wait. So where are we? Yeah. So basically, so we have packages. We render them. So what did we do in R2 to make the more flexibility? Is one is. So first of all, we had. Now we are going in network functions. So we did not do a lot of changes in the, let's call it, workload cluster space. Well, we did a few elements, but it was more to be independent of config sync, right? So we made it flexible that we could use also Argo CD or Flux as a GitOps pipeline. So we did some elements there to make it more flexible with respect to the infrastructure that is being used. For example, I know that John made it work on Google Cloud, and Alex has made it also an OpenShift plugin. So in other words, we, besides the sandbox which we use, which is using kind cluster, using cluster API, they built a set of, let's say, packages specific for Google with the specific distribution, if you will, or components that are relevant for the Google environment. And Alexis did the same for OpenShift, for example. So in other words, you see that you can reuse some of these components and then pick and choose the packages that you feel comfortable with. And as such, you can build your own specific instance based on that framework, right? On the network function side, so then what we basically did is we added, so originally when we deployed in release 1, we had a specific resource, so a specific CRD for SMF, UPF, and AMF. And it became clear that when we were going to the run, we needed one for CU, DU, and then depending on the way that you architected, multiple flavors. So we we went away from a specific deployment artifact towards a more generic one. So we went from SMF, AMF, UPF to NF deployment. And so the downside of ISO, the good thing about it, it gives us flexibility. So that means for any new network function component that we add, right? So like the RIC or something like that, we don't need to do a change with respect to the CRD, okay? The bad side of it, or the not so good part of it, is that the way Kubernetes works is that, so a controller typically is triggered based on that kind. So the kind is the NF deployment. So that's the resource itself. And because it's now, if you would have, let's say, 10 controllers for each specific vendor, each of them would be triggered even though they don't need that resource as such. And so we added the concept of a provider inside of NF deployment, such that the provider is then, so if you would have 10 controllers and you would deploy a UPF and only one of those 10 controllers is interested, each of the 10 will see that there is a request, but using the provider, they will throw them away. And only the one that is having that provider match will take care of that instance. So it gives us more flexibility going forward without us having to change the APIs every time there is a new network function type in our ecosystem, okay? We did the same or similar thing we did for configuration. So I was talking about that in the vendors or the configuration snippet. So we didn't want to go into a mode where we were going to reinvent all the 3GPP parameters that were defined by 3GPP, right? So we could have gone to a route where we said, okay, we want to specify or come up with CRDs for each of these 3GPP specific elements. And then the problem is then on top of that is every vendor has their own flavors of those. So what did we do instead is rather than having specifics, we built what we call a meta CRD, which is what is called config CRD. And that config CRD allows us to inject any configuration snippet that you can think of, and that can be 3GPP related, but that can also be vendor specific. And it's up to the vendor or the operator to identify which one they are. And so what we do is we then aggregate them together in that config CRD in order for us to give them, again, that flexibility. And it is the controller that consumes that config CRD. He will know the specifics of what is needed. And as such, he will then take action. So this was mainly done to add flexibility, again, for the reasons that we do not want to define for every new, let's say, configuration or new thing that we wanted to add, we did not want to add a specific CRD, nor did we want to be, let's say, going into a mode where we wanted to specify CRDs for all the 3GPP or all the specific environments that we were going into. Is that clear?
Hey, Wim, so on that particular one on the config CRD, what if you have a mixture of both, right? Is there two separate?
Mixture of what?
Mixture of both standard and vendor specific, right? For a particular.
You can, so the config CRD allows you to actually, it's a meta CRD. So if you can, those two CRs, let's say one is vendor specific and one is 3GPP, you can actually, so the config CRD or CR in this case will be able to aggregate both of them. No problem.
Okay, that's what I was asking.
Are those parameters part of your blueprint, Wim? I guess so.
So
Right?
so we have, yes, so we have packages right now that that contain those. So for example, if you go to, so in 3.5GC, so okay, so then we have now two test environments, if you will, right? So in 3.5GC, the 3.5GC one does not have that flexibility yet, right? So that hasn't made it till the in the end, right? The OAI one, which has both the core as well as the radio side, uses that completely. So in other words, if you look to the packages that from OAI for both core as well as for the RAM, it has that concept. So it uses that concept to convey the configuration snippets for that specific environment.
Is it just that we did not update the catalogs for 3.5GC? Or some other issue?
The thing is that the operator that 3.5GC was using, right, to add that flexibility came very late to the party.
Oh, okay. With the workload.
And so we didn't have time to accommodate all of these changes. So that's why it's not done in the 3.5GC deployment side. But we want to add it there as well, because today all the PLMN IDs, for example, they are hard-coded in 3.5GC, which we want to get rid of, right? So as such, you can, from the top, from the beginning here, you can say, okay, I want these PLMNs, and then they get deployed as such. Whereas today, the PLMN ID is actually selected at the operator in the workload cluster, which is where this limited flexibility comes from right now. So that's kind of more or less it. I mean, if you look to what R2 gives at its core, one also important element what we did not get to is that, for example, some of these 3GPP config snippets, you sometimes want to have it both in the radio as well as core. So we did not succeed in making that injection happen, such that you only have one 3GPP config and you add it to both the core as well as to the radio. So at the moment, what we do is we add it in all the packages by default. So that's some flexibility that we need to add to make that more flexible or less cumbersome, if you will, because now you need to add that in all these packages from the beginning, and that's not flexible enough, according to us. So we need to have some additional flexibility there.
What's common to the core in RAN? Well, I'm just curious.
PLMN ID, for example, or for example, not to all the radio, but for example, tracking area you need in radio as well as in AMF, for example, right?
So there's some fragments of certain
yes.
Certain information elements that are common across. All right.
Or slicing or something like that. So there is a number of them that and you don't need them in all the components, but in some, right? So then it's
but they're only going to be injected in the ones that they need them, right?
Correct. So that's the piece that we did not do so far. Yeah.
Okay.
One also important, the big thing is what we do not have at the moment, which is, I think, a big item that is important, is we don't have a really secure channel. So we have a secure channel from the management cluster to the workload cluster. So downstream, we do not have a good one yet. So, but we are flushing that out from security, from workload cluster to management cluster. So we have, for example, in the topology controller, we basically use the kube, so the full admin rights to get access to the data, right? But that's really unsecure. So we have to, we are working with the security team to see what we can do about that, right? So, but today our flow is mainly this way, and if you want to get, if you want to succeed in observability or even service assurance, we need to get this right. That's why I'm advocating service assurance. Let's do it local for the time being, and then parallel will flush this out, and we can do stuff here, and then we can aggregate it once we have that done. So yeah.
Yeah, but it wasn't just service assurance. Right?
No, we need it for multiple reasons, but so
Yeah.
it's a big ticket item that we need to resolve sooner than later.
Right. Because I knew that the ORAN guys had a couple of use cases that weren't SA related.
Yeah. No, I mean, in general, you want, I mean, if you want to solve the problem that Sarah was talking about, like service based deployments, right? Where you have both, let's say, an NF here and one here, one there, and then you want to get a visibility of what's going on, right? So you need some level of feedback, right? At least from my perspective, I believe that that's an important thing that we have to.
Very important,
Yeah.
Tim. We are working on service orchestration, right? And generally, and a lot of people are asking us questions. Why do we even need service orchestration? Why did the concept of NFPO in HC came in to begin with when we have Kubernetes? And I keep on explaining to them that what is missing in Kubernetes, why we cannot just rely on Kubernetes, and we still are using those Tosca-based templates, and we are using those NSDs concept, right? And then when they want to become very cloud native, I try to give them the answer that there is something excellent happening in the industry right now. I'm working in Project Nephew that is going to augment the Kubernetes layer to be able to become the de facto orchestration. And with that, Kubernetes will become the primary orchestration for us to do the lifecycle management, deployment, and everything around the telco network function, after which we probably might not need other orchestration solutions. So people are waiting for that. It's a big picture. Actually.
That's a big ask, Anna. I'm sorry. I guess.
Very slowly.
I gotta
give it 10 years. 10 years.
I'm just saying I wouldn't hold your breath for a while.
Yes. You know, some people are very cloud native. They're coming from the web scale world, right? They don't know what is SMO. They don't know what is ONAP. They don't know what's Etsy. So to just calm them down, I tell them something is coming down the lane, but how far it is, that we don't commit. So I'm there.
What I think it's going to be is, I think Wim said the same thing. I think that's one of the things that we can maybe help with is trying to figure out where that delineation point is at, right? A reasonable delineation point is, because I don't think it's all going to be in the Nepio realm or all in the SMO realm. We've got to go figure out a happy medium.
Absolutely.
Yeah.
Tim, on a very high level, my perception or the picture in my head is that the O1 interface could be a good focus for Nephew. The rest might evolve with the ORAN and SMO, but we should have a very close interaction with ORAN in general around the O1 interfaces and whatever is happening there. And of course, Nephew will not be boiling the ocean. Everything won't be happening through Nephew. It will establish a collaborative relationship with the other components and bring something to business very soon.
Yeah, but even that has got to be, so there's work going on in ORAN, talks about cloud native OAM, right?
Yes.
Which is the O1. And even then, the focus of that is on 2 points. One that we're actually dealing with. One is for configuration management, right? Using more of a cloud native configuration. And the other is dealing with telemetry, trying to get the data out and into the right repository. It's more of our observability. So there's pieces in there that, you know, the industries, both sides of the industries are working on. It'll be the challenge is to see if those, you know, that you can come up with a cohesive solution, right? That can work between the two.
Right.
So.
And there is one more bottleneck to that vision, Tim. Besides aligning the ideas of Nephew, the cloud native patterns and possibilities, and how to align with the ORAN specification and their requirements, there is a third factor, that is the evolution of the network functions, that real VCU, VDU, current state of where they are in the cloud native journey.
Well,
so
hang on, Sandra. Just to follow up on the first one. You talked about
Yes.
O1, ORAN.
Right.
But again, you know, I'm actually, it's a larger industry question for telco, right? It's a question because if you look at, you know, WIM's got the fixed line stuff that's got the routers. That they're even more, you know, focused on the point-to-point or manager to managed entity architecture that they don't necessarily have anything that they can move from, particularly for configuration. Correct me if I misspoke, Wim, but you know, this is a bigger problem than just mobile. It's a question across how do I deal with configuration that is.
We do. So Tim, wait and see. You'll see something very big soon. So it's like.
Yeah, but to the NF, Wim, to the NF, it looks like it's the normal interface. What you're talking about, right? With the Yang operator, right?
Yeah, I mean, so for us, it's basically everything through Kubernetes, right? So you basically, so it's basically everything through KRM and as well as service assurance, right? So it's basically the whole stack, modernized.
But not the NF itself doesn't utilize the cloud native aspect. They utilize
NF has to
standard
transform as well, Tim. There is a separate initiative that we are working on. Of course, that will take time, but NF has to modernize as well. You're right.
But look at what we did in Azure Linux, right? It's completely cloud native, completely.
Right. But we did that the free open source components. When you go to the commercial NF.
No, this is commercial, by the way. So this is certain pieces of it, but we rewrote it from scratch, by the way.
Okay, good.
Yeah, my point is, like, even with an ORAN, that's the thing that they're looking at is, you know, saying, okay, how do I move into a more cloud native piece of this where I have configuration that isn't traditional, you know, point-to-point conf yang type of stuff, or telemetry using, you know, traditional file transfer, that type of thing, right? So the industries are working on the problem. We just got to make sure that what we're doing, you know, goes across domains, right? Because we're working on multiple domains even within telecommunications. That's the biggest concern I have when we talk about O1. But go ahead.
Yeah, one question I have for Sana is, I mean, Sana, when we're talking about O1, right? O1, you're talking about some kind of an interoperable OEM functions that can manage multi-vendor kind of network functions, right? But you have the EMS component. So are we talking about, when you say O1, are you saying still a kind of a generalization layer that we do today with the kind of R1, R2 implementation with config refs and so on? Or are you really saying that you will have vendor-specific EMS functions in the management layer, or in the Nephew management layer? How do you envision that? How do you solve that problem?
Yeah. So Ravi, I try to solve the problem like this in my mind. I believe that all the ORAN vendors for the infrastructure that we are receiving today are all on Kubernetes. So when you see the Kubernetes as a common denominator across all these hybrid cloud providers, 80% of the stack becomes common. The rest of the 20% is different. Okay, so going from example to example, go from OpenShift to Wind River to something else across the world, the 20% is different. So the way we try to solve the Nephew problem for the common packages and the variant and variant set, I believe there is something similar that we can do for the variations of Kubernetes distributions, and we could still handle a common IMS for them with that approach. Did I answer your question?
No, my question was more on the O1 interface. You said because that's where the OAM, the CM, FM, PM for every vendor telemetry
FM, PM,
configuration app.
yeah, it's all the same. So if all of them are using Prometheus, and if you try to solve the OAM problem like with one common interface, I think we will be able to solve it if there is something in Nephew that supports multi-vendor OAM capabilities. Essentially, at the back end, there will be some open source, like something like Prometheus or some data source that is still common across these various cloud distributions.
Mm-hmm. Yeah.
I cannot oversimplify. I know that the heterogeneity or the complexity or the customization on the ground is sometimes more than what we anticipate, but at least from Nephew community, we need to offer something that is common across these heterogeneous distributions of the ORAN cloud providers, which is where I see that this could be an opportunity for Nephew to standardize that, to drive that, of course, to have a very close collaboration with ORAN and drive that.
Yeah, with cloud providers, I'm okay. I'm just seeing from the other
the network function.
Yeah.
Network function.
That seems to be more evolved. Kind of, it's like so much of
network functions are super behind, Ravi.
Right.
I completely see where you are from, at the moment. Network functions are really behind, and there is a separate initiative happening on network functions as well. I'm leading a lot of work in Linux Foundation. The separate initiative is the Cloud Native CNF. The CNF testbed I wrote in the NGMN publication about the Cloud Native Network Function. I think Bernard and Eric, they all know because Orange contributed to that. Those network functions are behind, and the RAN network functions are super behind. Look at the video VCU. They have a long road to become cloud native. So I agree with you. Their analytics, their data isn't in Prometheus for sure. It's very proprietary EMSs where their telemetry is residing today. And we're probably talking about roadmap when we talk about all of this. So it's an evolutionary path where everything is.
Mm-hmm. And I think they're also all using different protocols for management. So
yeah, SNMP is still there. Like we are in Kubernetes, been so many years, we're still stuck in SNMP. So I know the reality on the ground, Ravi, and I know where your thoughts are coming from. Even in the 5G core, been 5 years, 4 years at least, we have containerized our 5G cores. We still have SNMP on the CNF. So things are not fully cloud native, and I think it's something that would eventually be happening across the industry. Things are much better than before, for sure. Hopefully they are getting better in the future as well, and this Nephew's concept will become successful. We couldn't go to the working group discussion because we had an excellent discussion on understanding the current state of the Nephew development, which is going to help us brainstorm on the R3 user stories. In my mind map, I have been asked by Kandan to come up with the R3 scope in a way that is actually helping us look at the business view. So what are the current capabilities, what's done, what needs to be done that can actually drive value for us. So I'm almost thinking of a theme when Alexi comes back, maybe we can brainstorm on giving TSC an R3 scope proposal. We have the use cases coming from different working groups, and use cases are vehicles for us to drive the transformation of the existing components and bringing new components. So maybe we need to do one session in looking at the Nephew's existing components and how those components can drive the capabilities that can actually solve some of the business problems for telcos that are actually on the way. For example, service assurance, for example, the modeling problem that we are looking at. Then by looking at the two sets, the use cases that are on the hand, and how those use cases are helping us drive those components development further is, I think, a model that we can use to brainstorm the R3 scope, which will then align us with how Tim's thinking in SIG2 and how SIG1 is thinking in advancing the various working groups roadmap forward.
Yeah.
So an
but it should be probably more on R4, I think, right? Because R3, I mean, look at it, we are February, right?
Oh yes, we're always behind Wim. So whatever we do
no,
now,
but it's okay. I mean, see, we are a continuous thing, right? So, but I think R3, I have the feeling our scope will be fairly basic from my point of view, because see, we have to deliver some. If we are not focused to do, you have somehow to deliver some, but that doesn't mean that we don't have to think about the next steps, right? So we have to. It's always this balance. But what we should avoid doing is this waterfall model.
Yeah, completely
should-
understood.
Yeah, we should try to continue and try to evolve and solve because see, there is one hand, I always try to balance between what we really would like to have, but what we really
Can have.
need to do. So,
Right.
because I look at this, right? If we don't solve this problem, forget about a lot of stuff, right?
Agreed.
That we want to, or that we should do, but we cannot do, because if we don't have this properly solved, we get stuck a little bit, right? So there is a
Right.
number of building blocks that we need to get done to move forward. So that this is the chicken and egg type of stuff.
I completely agree. Wim, as long as together, from SIG1 perspective, if we can give the channel the direction of the stream can keep flowing through it. And doesn't
Correct,
matter,
yeah.
R3, R4. So we need to at least give that channel a direction. Like that's how we want this to evolve. Then you can pick up whatever can be done in R3, R4. These are basically just milestones along the way. So
Yeah, but
Oh.
Santa, just to be, let me
Yes.
just go from my
Go ahead.
perspective here, right?
Go ahead, Wim.
Is that, you know, from an ORAN, you know, for me, for release 3, the candidates for release 3 is, I call them in the can. They're already done, right? We're not going to be able to look at anything more from a use case for release 3. In fact, I'm expecting once we're done with the scoping, maybe some of those will have to come back as release 4 candidates. I don't know. Not worried about that, but they're in the can. But I think what you're talking about is what I'm looking at going forward, that I want to get the team focused on in the March, April timeframe, is starting looking at what's next after release 3, so I can get to release 4 and release 5, with the hope that eventually I can get a roadmap out of this thing that can go a year, right? Give me a year in a view, right? Two releases ahead, or have, I guess we're doing 2. Give me
Absolutely.
3 and 4, right? You know, but I know we have to walk towards that, right? And so so the stuff that you're talking about is great, because I'm going to take it release 2. I'll know what candidates are release 3 there, and we can start identifying the things that we want to do, our objectives for release 4. And I wanted to started doing that in the March, April timeframe. Right now it's kind of iffy because, you know, it goes as the guys are able to do the work, right? So, but that's the whole idea. And I think that's what you're trying to get at as well, trying to figure out what we're going to do for the next releases. But
excellent, Tim. That's an excellent thought process. That's exactly where SIG1 has to establish that guiding path, and we need to evolve this project according to that roadmap. And what is that roadmap? Things were very unclear when we were working in the beginning. Things are now coming in a shape, in a form where we can think about building that roadmap. And that roadmap would be built by looking at how the ORAN is evolving, how the service assurance is evolving, how do we intersect between these two? What are the candidate use cases that help us push forward on developing those business capabilities across these components, which is going to make Nephew useful in the short term? So if today I download a Nephew open source project and I try to use that for something in TELUS, now these components are actually functioning. It can give me a value right away. So maybe I could start using it, but we continue to evolve. So we'll keep working. And had a very good session. I learned a lot. Thank you so much, Wim, for that. We couldn't get to the working group updates. Wim, if you could share the link to this presentation, I'll put that on the meeting notes, and meeting notes are published. I was taking notes in the background.
Yeah, this is public. I actually gave this during the weekend to an open source conference, by the way.
Okay, very nice. I was looking for the link, so I could
yeah, I'll share it.
Put that in the notes. Thank you so much. Thanks, everyone.
Thanks, Wim. Yeah,
We'll see
thank
you
you.
again. Bye.
Thank you.
All right. That's it.